In this video, we're going to look at applications involving linear equations. And we're first going to do a quick review of solving systems of equations where you have more than one equation. So let's look at our two methods, the elimination method and the substitution method. We'll start with the elimination method. So it says the rules for solving by elimination is to get both equations in standard form. So ax plus by equals c. And then we'll go through the steps as I work example 1. So in example 1, I have 2x plus 3y equals 1, so it's in standard form. Negative x plus y equals negative 3. It is also in standard form. I can see by looking that I could eliminate my x's if I multiplied this second one by 2. The first one I'm going to leave as it is. 2x plus 3y equals 1. Now, how did I know not to multiply it? Because I want the coefficient on my x terms to be the same but opposite signs. This one is already a positive 2, so by multiplying this one by 2, I get negative 2x plus 2y equals negative 6. You multiply each piece, each term of the equation by the same number. So that's why I didn't want to multiply the top one. Now that eliminates my x's, and I have 3y plus 2y is 5y. 1 minus 6 is negative 5. I divide by 5, and I get y equals negative 1. Now remember, what you're looking for is a point of intersection of these two equations. That is our POI, or point of intersection. So we just found the y piece of that. We now need to find the x piece of that. So I'm going to go back to my first equation. 2x plus 3, I'm going to substitute what I found for y and solve for x. Add a 3 to both sides, and I get 2x equals 4, divide by 2, and I get x equals 2. So my point of intersection, which is the same thing as saying the solution to the system, my point of intersection for these two equations is the point 2, negative 1. All right, let's do the same thing using the substitution method. So in the substitution method, one of the two equations has to easily be solved for either x or y, meaning one of your variables needs to have a 1 in front of it. This one does, so I'm going to solve it for y by subtracting a 2x from both sides. And that gives me y equals 5 minus 2x. This becomes my substitution equation. And I substitute it into my other equation. So negative 4x plus 6, take out the y, put in the substitution. 5 minus 2x equals 12. Negative 4x will distribute, plus 30 minus 12x equals 12. Combine like terms. Let's move this up so that you can see. Combine like terms. Negative 16x plus 30 equals 12. I'm going to subtract a 30 from both sides, and I get negative 16x equals negative 18. Negative 30 take away, or negative 30 and a positive 12 is a negative 18. I've got 18 more negatives. Now I divide by negative 16, and I get that x is equal to a negative divided by a negative is a positive. I'm going to divide each of these by 2, and I get x is equal to 9/8. So my point of intersection, my x part, is 9/8. To find the y part, I'm just going to use my substitution equation again. So y equals 5 minus 2 over 1 times what I found for x. I can cross cancel. Y equals 5 over 1 minus 9/4. Now I need an LCD, which is 4. So y equals 20 over 4 minus 9 over 4, which is 11 over 4. So the point of intersection is the point 9/8, 11/4. And that is the solution to that system. So that was just a quick review on those two methods because we're going to be using those methods for application problems. So let's look at the first application, and we're only going to be doing mixture problems. Those are the only applications we're going to be doing with systems of equations. It says Candy has $70,000 to invest and requires an overall rate of return of 9%. So that is her objective. That's her target, is the 9%. She can invest in a safe government-insured certificate of deposit, but it only pays 8%. So she's going to have an amount of 8%. But to get her target, to get the 9%, she agrees to some non-insured corporate bonds paying 12%. How much should be placed in both investments to achieve her goal? So what we're going to do is we're going to say let X equal the amount that she's going to invest at 8%. That was the first type. So Y is going to equal the amount that she's going to invest at 12%. Now I can draw a little picture here to help us. So here is the amount she's investing at 8%. Here is the amount she's investing at 12%. Altogether, we know how much she has. She has $70,000 and she wants to get 9%. I need two equations out of this picture. I need an amount equation that comes straight across the picture. So X plus Y equals 70,000. And I need a value equation. It is the same as this one, but the labels are in front of it. And if you will remember, you can't use percents in calculations, so we're going to change these percents to decimals. So what I still have is X plus Y equals 70,000, but in front of those I'm going to put the values. So 0.08X plus 0.12Y equals 0.09 times 70,000. Now I'm going to use substitution. You may use elimination if you choose, but I'm going to use substitution. So I'm going to subtract an X from both sides, and that's going to give me Y equals 70,000 minus X. And this becomes my substitution equation. Where does it get substituted? Right there. So I have 0.08X plus 0.12, take out the Y, put in its substitution, 70,000 minus X, equals, go ahead and if you multiply that out on your calculator, you will get 6,300. Now it's just a calculator problem. 0.08X we're going to distribute, plus 0.12 times 70,000 is 8,400, minus 0.12X equals 6,300. We're going to combine like terms. Negative 0.04X plus 8,400 equals 6,300. Subtract the 8,400 from both sides and you get negative 0.04X equals negative 2,100. We divide by negative 0.04 and you get X equals 52,500. So that's how much she is going to invest at 8%. To find out why, you go back to your substitution equation and you say 70,000 minus what you found for X. And that will give you 17,500 that she has to invest at 12%. So this was basically just a setup and calculator problem. Let's try another one. The more of these mixture problems you do, the better you will become. And this is one of the objectives in college algebra. You have to be able to do a mixture problem. The manager of a Starbucks store decides to experiment with a new blend of coffee. She will mix some B-grade Colombian coffee that sells for $5 a pound with some A-grade Arabica coffee that sells for $10 per pound to get 100 pounds of the new blend. Now let's stop there for just a minute. Let's get organized. So let's let A equal the amount of the Arabica, and we will let C equal the amount of the Colombian coffee. Now I'm going to draw a little picture. Pardon the artwork. Those are bags of coffee. So she's got two different kinds. She's got the Arabica and the Colombian. Those are amounts, so they go in the bag. And all together, she's going to get a big bag of coffee. And how much? Right there. She's going to get 100 pounds. Now we're going to put the labels on. The Arabica is $10 a pound. The Colombian is $5. And finishing reading, it says that she wants to sell the new stuff for $7 a pound. This is easier than the percentages. So my two equations, my amount equation reads right across the picture. So A plus C equals 100. I'm going to go ahead and solve that for C by subtracting the A from both sides. And that is going to give me my substitution equation of C equals 100 minus A. That is going to be my substitution equation. My value equation, remember, is the same thing. A plus C equals 100, but it has the labels in front. So 10A plus 5C equals 7 times 100. Or 10A plus 5C equals 700. Now I'm going to make a substitution for C, and it's going to be this right there. So we have 10A plus 5, take out the C, put in the substitution, just like we did, equals 700. Distribute 10A plus 500 minus 5A equals 700. Like terms, 5A plus 500 equals 700. Subtract the 500 from both sides. 5A equals 200. I subtracted a 500. I didn't show that step. Don't freak out. Divide both sides by 5, and we end up with A is equal to 40, and that is 40 pounds of Arabica. Now to find C, we go back to the substitution equation. C is equal to 100 minus what we found for A. So C is equal to 60 pounds of Colombian. I actually think this was easier than the other one, but it's not about me. Let's do one more that has one thing that is a little bit different, but it's still a mixture problem. A movie theater sells tickets for $8 each, with seniors receiving a discount of $2. Now, it doesn't say that their ticket costs $2, right? It's a discount of $2. So how much is their ticket? Their ticket is $6. So right there, there's something different. One evening, the theater sold 525 tickets and took in $3,580 in revenue. How many of each type were sold? So we are going to say, let X equal the number of $8 tickets that were sold. So Y is going to be the number of, remember, it's not $2, it's $6 tickets that were sold. Without drawing a picture, I need an amount equation. My amount equation will be tickets, amount, X plus Y equals how many were sold? 525. I need a value equation, and this is where this one is a little different than the last ones. It's still going to be X plus Y, but on this side of the value equation, the work was already done for you. We already know how much they took in. So it's 8 is the label for X plus 6 is the label for Y equals, I don't have to say 525 times some amount. It's already been figured. I just write that amount. So that part is a little different. I'm going to subtract an X from both sides to get my substitution equation. 525 minus X, and now I'm going to substitute that right there. So we have 8X plus 6, take out the Y, 525 minus X goes in its place, equals 3580. 8X plus distribute that 6, you get 3150 minus 6x equals 3580. Like terms, 2x plus 3150 equals 3580. We're going to subtract the 3150 from both sides, and that gives you 2x equals 430. Divide by 2, and we get x is equal to 215 $8 tickets were sold. Now we need y. So I go up here and I say y is equal to 525 minus what I just found for x. So y equals 310 $6 tickets were sold. I hope you see that these are all the same. Every single mixture problem has an amount equation and a value equation.